We've discussed this in class before, and whenever we see an equation in which we have our variable up in exponents, there's really only one tool that we have, and this is the strategy. The first thing we're going to do is we're going to attempt to rewrite, W-R-I-T-E. So the left and right-hand side, the left-hand side and right-hand side have the same base, right? And we'll simplify. And because our left-hand side and our right-hand side will have the same base, the only way that they can be truly equal to each other is if the entire exponent on the left-hand side equals the entire exponent on the right-hand side. So that's what we'll do then. We set, the second thing we do is we set exponents equal to each other. And solve. So if I look at 3 and 9, I know that there definitely is a pattern there, right? 3 times 3 is 9, right? So we're looking at multiples of 3 here, 3 squared versus 3 to the first. So when I identify what my base is, a lot of times I'll just write, for example, 3, that's 3 to the first, 3 to the second, 3 to the third. I might extend it, 3 to the fourth, 3 to the fifth. And actually, I can go the other way too, right? 3 to the 0 power, 3 to the -1 power. So all of these. So if I look at 3 to the first, that's pretty easy. That's the number 3. 3 squared is the number 9. 3 to the third is 27. I don't need all of these. This is 81. Just writing down a few. 3 to the 0 power, that's always going to be 1, right? Anything to the 0 power. And if you look, as I move forward here, it's times 3, times 3, times 3, times 3. If I want to go backwards, I could divide by 3. So that's kind of an inductive argument for why 3 to the -1 is 1/3, right? So here we go. I can see the two things I need. One of my numbers is just going to be plain old 3, which is 3 to the first, right? So that's not going to change at all. The other side, however, this 9, we're going to rewrite as 3 squared. So here's how I transform this equation. This equation is going to become the following. We're going to write still 3, but 3 to the 4x minus 1, and that's going to equal, now, what is 9? 9 is 3 squared, and we're raising that to the x power. So using one of our laws of exponents, I'm going to simplify this left-hand side. This has to be 3, the base of 3 raised to the 2 times x power. And over on the right-hand side, this is 3 to the 4x minus 1. So again, the only way that these two quantities can be equal to each other, right? They can only be equal is because they both have the same base of 3 and base of 3. The only way that this can be true, that they're equal to each other, is if those bases, are indeed the same. So we're just going to go ahead and set the bases equal to each other at this point. So we're going to say, look, we need to know when this exponent, rather, the exponent 4x minus 1 is the same as this exponent. And, to solve this, lots of things I might do. I'm actually going to do this because I see this mistake made often. I'm going to subtract 2x from each side. When I subtract 2x from the left-hand side, it does become 2x minus 1, right? 4x minus 2x is a 2x. On the other side, we end up with a 0. And a lot of times what I see happens is people will take away 2x from both sides and they just write the 2x minus 1. And they forget that this other side is 0. It's still there. And then that lets me finish, right? I can add 1 to both sides. So I get that 2x is positive 1. And then if I divide both sides by 2, I get that x is 1/2. Now, this isn't magic. Only if x is 1/2 works is this true, right? So let me show you how I check this one. I'm going to go ahead and turn on the calculator, take 3, raise it to the power up, and then I'm going to use parentheses so I can get everything that's in this exponent. So I'm going to say 4 times 1/2. I guess I'll do it as a decimal. 4 times 0.5, and then minus 1. And close the parentheses, and it equals. And you can see that gives me the number, that's interesting, gives me the number 3. Okay, so when x is 1/2, this side became a 3, and we're wondering, is the other side the same? So let's take this 9 and raise it to the open parentheses 0.5, or actually I can do 1 divided by 2 also. So 0.9 raised to the 1/2 power, and when I do that, I indeed get 3, right? So this value, x is 1/2, is indeed the value that makes both the left-hand side and the right-hand side of that equation the same. It makes them both 3, so therefore it is a solution.